join us to the next talk of the day. Don't worry, this talk is going to be a lot less technical than the previous talk. So hopefully you guys understand this a lot better. And again, if you guys have doubts, you'll be able to ask at the end of this session. So this is going to be a problem that almost all big online services are going to face, that is scalability. Here to tell us how big tech giants achieve this is Satyamurti. Please give a round of applause. So, do you guys know that Google handles 8.5 daily searches, 8.5 billion daily searches, and that too in 150 languages, and still you get a lightning fast results. Do you guys know that more than 1/4 of world population uses YouTube every month? Still you get 1 billion and 1 billion hours of content is watched every day. Do you guys know that during COVID-19 Zoom's daily users skyrocketed from 10 million to 300 million, and that too span of 4 months. They had 300 billion plus meeting minutes hosted in 2020 alone. So how did they pull it off? How did they manage to handle so much load? So greetings everyone. My name is Satyamurti, BTech 4th year CSE. I am going to talk about fascinating topic called global scalability. This is the magic behind big tech's worldwide reach. So first of all, starting with very basics, what is scaling? When the company's product get more popular and popular, new users start adding to the platform, and scaling means adding more computers and the resources so that it can handle all the new users without slowing or crashing down the website or application. So this is all about scaling. Then next question will be what is server? So think of a server like a big computer, that holds all the information and files that is needed for the website. So when you open any website or app, it will talk to the server, and it will talk to the server and get back all the information needed that is that we can show to you. Okay. So these were two terminologies which I will use again and again so that you will be better understanding further topics. So let's take one more example. So how many of you watch cricket here? I am sure many of you do. So if you remember last World Cup match, India versus New Zealand, that happened in 2019. The match happened for 2 days, like day 1 and day 2 because of rain. And unfortunately, India lost the match. But there are some interesting facts over here. So unfortunately, India lost the match, but Hotstar, the platform which was streaming this match, made a world record of having 25.3 million users watching a match at the same time. This was the moment where they made a world record. So we talk about it how 25 million is a really big number, right? So think of it like a big concert. So if you have 25 million people attending your concert, so it will be a chaos, right? So but if any software or application is scaled properly, it can handle this much load seamlessly. So this is the scale we are talking about here. So we'll discuss how they did it and how they did it and what are the technologies they used it behind. Okay. So let's find out. So Disney plus Hotstar, they had a project called Hulk. So they can use these names because it's backed by Disney. So the project Hulk was responsible for building this great architecture which was able to handle this much load. So we'll talk about this project Hulk in a bit, but it's time to explore the tech behind all of this. What are the technologies used behind scaling? Like how the big companies are achieving this. Okay. So again, if I talk about technologies one by one, it will be boring lecture, right? So how about a story? Let's build our own company by scratch. Okay. So Dipesh, the guy who gave a talk before, consider him as an aspiring entrepreneur, and he wanted to create a social media platform called a friend space. So this is social media platform like Facebook, Instagram. So he wanted to create that. So he created an application, but now he needs a server to host it. So obviously, if you want to buy a physical server, it's not affordable for a student, right? So he was looking for the way to rent a server machine. so that instead of buying a whole machine, he can just rent for a temporary period. Then he came to know about cloud computing. So what is cloud computing? So cloud computing is a computer situated somewhere in the world and you can access it using internet. So there are big companies like Amazon, Google, Microsoft. They have their own computers situated somewhere in the world and you can access them. You can rent them and use it over using internet. So this is all about cloud computing. So Dipesh got interesting. This is this is the way to go for him to build an incredible product called Friendspace. Now, how did he do that? So what he did was he went to a cloud provider. Let's say example Microsoft. So then he said, okay, I want a virtual machine, the virtual computer which can access using internet. Then he got this virtual machine through a cloud service. So all these big companies, they provide cloud service. For example, AWS, Google Cloud, or Microsoft Azure. So he got the virtual computer through the cloud services called Microsoft Azure, and he hosted his own website. Now, it has hosted. People are using the Friendspace. It is becoming popular day by day, and people are liking it because the way he coded it was it was really impressive. So there is a new one. There is one new problem here. What is the problem? Each server can handle only 500 users at a time. But as the app was going viral and it was becoming more popular, there were more than 500 users using at a time. So his server was slowing down. So what did he do? So basically Dipesh added more servers. So now he added more servers. So you need someone. So he's thinking, how can we distribute the load, that is the network traffic of users to these servers? Because I have many servers, but I don't know the way to distribute them to among the servers, right? So that's where he came to know about load balancing. So this is one of the interesting topic, technology used by many big tech products to distribute the traffic to multiple servers. So what is load balancing? So consider load balancing as someone in middle who will see what is the traffic load. The traffic load in the sense how many people are trying to use the application, and based on that it will redirect, distribute to the servers, so that it will make sure that no server is overrun or no server is sitting just idle. Okay, this is the main work of load balancer. So to make it more simpler, I'll just relate with the story. So when you guys were in nursery, you might have heard of two cat and one monkey story, right? So basically, there are two cats. They find a piece of cake. Now they want to distribute among themselves. So they started fighting each other because they don't trust each other. Now there comes a cunning monkey, which will who says like I'll distribute among you, and it starts eating one piece by piece from both the sides, and it eats over the cake. Okay, whole cake. So load balancing is also a monkey here, but it's not cunning one, it's a sincere one. Instead of eating a cake, it will make sure that it is distributed equally among both the cats. So cats are basically the servers, and the monkey is basically a load balancer here. So I hope this will make more easier for you to understand. So okay. So there are some load balancing algorithms which you should know. So first one is dynamic load balancing. Second is static load balancing. So these are the two types of load balancing algorithms. So let's look into what is static load balancing. Like it's an easier one, right? So static load balancing is if I have to simplify it, it's a hard-coded algorithm. So it's a hard-coded algorithm when there is a traffic, it will just use that algorithm to distribute load. So first let me take example of round robin. So what is round robin? So let's say there are 10 friends and they want to play a card game, right? So how do we distribute the card? You just make them sit in a circle and you distribute one by one, right? So this is how you distribute the card. So it's the same thing in round robin. So what it does is it will distribute the load one by one to server. So this is just a hard-coded algorithm, and there are many hard-coded algorithms which are used to do statically load balance. Okay, so the problem over here is, we don't know how many requests we get, at any certain time, because some people might use the app at night, some people might use at 12 a.m., maybe 12 p.m. So the traffic is fluctuating, right? So you need something more better algorithm which can distribute the load among servers, so that no server is overwhelmed, or no server is sitting just idle. So that's where dynamic load balancing algorithms are used. So first example is least connection load balancer. So what is least connection load balancer? Least connection load balancer, what it does is it will just check which server has lesser connections. So if some server has a lesser connections, so next time whenever there is a new traffic, it will redirect to that server. So this is how least connection load balancing algorithm works. So this was all about algorithms. You can obviously go search about load balancing algorithms and learn more about them. This talk is not about going into too much technical details, but instead giving exposure to how the big tech products actually scale them. Okay, so we move on to next problem. So now Dipesh used load balancing algorithms to balance his traffic load. Now servers are working really good, but there is one more problem over here, guys. So Dipesh friend space went viral. Okay, not only India, people from US, people from Singapore, they started using friend space. Okay, now the problem over here is they started complaining that, hey Dipesh, I see my app is loading very slow. Why is it? Why is my app loading very slow? Then Dipesh, he got confused. He checked in India it's very smooth, but in USA it's very slow. What is the problem over here? Then he found out that the people who are sitting in USA, they are hitting to Indian servers. So if they want any content, they are coming to they have to hit to the Indian servers to get the content, right? Because servers are located in India. Due to this much big space, this much big length between distance between both of them, there is performance issue. That's where Dipesh found out another interesting technology, or you can say solution for this, that is content delivery network. Okay, what is content delivery network? In simple terms, it brings content closer to the user. So if you are sitting in USA, or if you are sitting in India, what CDN will do is it will bring content closer to you, so that there will be better efficiency, right? So let me just explain through the just a diagram over here. Okay, let's say the red server, you can see here, these are the servers. Okay guys, so the red is the original server. Okay, so this server is located in USA. So obviously the people who are in Australia or India, the performance is really slow because it's too far. Now what CDN does is it will deploy the multiple servers over the globe, and these servers are called POP. POP is point of presence. What is the main work of this POP is basically to store the huge static content, that is temporarily store the huge static data, so that whenever a new user from Australia wants to access the app, instead of coming all the way to original server, it will just find the nearest POP and get the content. So this is how CDN saves a lot of time to get the data, and this is how it will not only improve the efficiency, but also it will save from the disasters. For example, once server is down, it can easily move to the nearest next POP, right? So this is how the CDN is used nowadays. YouTube, Netflix, all of them use CDN. Even Hotstar is using CDN. So now everything is working fine. We use CDN. Now people are happy in US, people are happy in Singapore. Now there is a next problem. Now Dipesh is his app went viral. People, millions of people started using his app. Now he is wondering why the database queries, the queries which you do for database, right? Read, write, they are getting slow. Then he found out that the database was becoming bottleneck because the queries were really slow, and even though there is a CDN, even though the efficiency is good, but the response time from the database is really slow. Then he found out that the database, the actual database is so big now, it can't be handled by one server. So there should be some way to distribute the database into multiple servers so that they can efficiently handle it, right? So then Dipesh and his team, they found out a new way, that is database sharding. So this is one of the used technologies nowadays. So what is database sharding? Okay, simple terms, it breaks data into smaller parts. So if you have a database, it will just break the database into smaller parts so that each part can be assigned to a different server, and that server will handle only that part. It doesn't care about the rest of the database, so that it is more efficient. And if database becomes more larger and larger, you can horizontally grow as well, right? So again, what is database sharding? Break up the database into small shards. We call it as a shard, not the parts. So these smaller shards, so there should be something unique ID, right, to identify which shard it is. So we have a hash function which will generate a key. That key is known as shard key. So this is a unique key which will be representing that respective shard. So I'll just explain to the diagram. Okay. So this is the main database here. So let's say, for example, you have a student data. So the column 1, let's say it's the roll number. Okay. So what database sharding means is you distribute 1 to 100 roll number into one shard, 101 to 200 into second shard, 201 to 300 into third shard. So this is how you split the database, and each shard will have an shard key that will be generated using hash function. And whenever above this, there will be a load balancer. So load balancer will be sitting above this, and it will decide which database to go. Okay, based on the shard key it receives. So if the base roll number is 29, it will go to the first shard. Okay, this is overall what's happening here. So now Dipesh fixed the solution, the problem of having a database problem. Now he used CDN, he used database sharding, he used load balancing, everything. Now his app went viral. He made a lot of money now. Now he's happy. So I think we can end his story now, because these are the major technologies which are used in big tech products to scale. So let's move on to the project help of Hotstar. This is real shit which is happening here. So project help, how did they handle 25 million people watching at the same time? Okay, so there are 4 stages over here: load generation, tsunami testing, traffic pattern using machine learning, and chaos engineering. So what the team of Project Help did was, they initially before match itself, they tried to simulate the thing. Okay, so what they did was, they did the load generation part. So here you use thousands of computers located in India or located in the globe to generate huge traffic load, and that load will hit to backend servers of Hotstar. So as they hit to backend servers of the Hotstar, their load balancer will start distributing load to different servers which are available. So load generation will not only give the inputs how your servers are working, but also it will make sure that it will also anticipate the problems which will happen during the real match. So there are 2 interesting facts over here. First is tsunami testing, and second is traffic pattern using machine learning. So this is kind of new, which you might be interested in. So first is tsunami testing. So what is tsunami testing? If you look into this the pattern over here, so this is the people watching at the same time. Like this is a concurrency pattern. So where at certain time, what is the number of people watching the match? So you can see here the match was divided into 2 parts, day 1 and day 2. Okay, because of the rain, and the maximum people watching during New Zealand batting was only 30 million. This shows how India's batting is popular. Okay, So now at this point, okay, where my laser is pointing, right? This point, Dhoni came into batting. When Dhoni came into batting, everyone had again hope in Dhoni that India will win this time. So you can see here there is in few minutes the viewership went from 10 million to 25 million. So in very short period of time, 15 million additional users added to the platform. This is called as tsunami moment, where in very short period of time there is a huge load on the servers. So this is tsunami moment, and this is where most of the architecture fail. So that's why it is very necessary for Hotstar to do the tsunami testing before itself. So how did they do that? How did they actually handle the situation in the real match? So there comes machine learning. So they made a use of machine learning to anticipate what will happen. Okay. So if Mahendra Singh Dhoni comes to batting, machine learning will anticipate that the viewership will go up. Okay. There will be tsunami moment. So the machine learning model or algorithm anticipated that there will be tsunami moment when Mahendra Singh Dhoni came to batting, and this was already known by them, known before the actual moment happened, and they as soon as Mahendra Singh Dhoni came to batting, they pre-scaled their servers. Okay, so this is how Hotstar made use of machine learning to not only make it more scalable, but also help them to detect the tsunami moments. So this is how machine learning is helping here. So there are other ways as well. So where machine learning is helping. So one is machine learning also helps to adjust resources. So let's say Dhoni got out. So when Dhoni got out, unfortunately we all know that India might lose. So that's what happened. So people start, as soon as Dhoni got out, you can see here there is a steep drop here. This was the moment where Dhoni got out, and it was a run out. So as soon as Dhoni got out, people started leaving the app, right? People started leaving the app. So what machine learning does is, if there is less traffic, there is no need to spin up the remaining servers, right? So it can just close the servers which are which are just idle. So this is all handled by machine learning. So another is predict peak traffic. That's what I explained before, right? So when there is Mahendra Singh Dhoni came to batting, this was the moment where it detected that there is a tsunami moment, and it again pre-scaled. They scaled the servers before itself so that there won't be any issues, and the match will run smoothly in every single everyone's phone, right? So this was all about machine learning. So yeah, what have we learned so far? Okay, just to sum up, what have we learned so far? So first one was we went on looking into cloud computing, how Dipesh used cloud computing to make sure his app is working smoothly and it is scaled efficiently. Because if you want to buy a physical machine, it's really hard, right? And it cannot scale also. If you have to keep on buying physical machine, right? That's not the way to do. So we look into load balancing as well. So how, if there are many servers, how the traffic is distributed among them. And I related with the cat and monkey story so that you can understand better. There is also CDN. We looked into CDN, how if you want to expand globally, how CDN is useful, how people from another region can easily get the content, and there is no performance issue. Then we went to look into database sharding, where if your database is becoming bottleneck, you can easily use database sharding technique or to distribute your database. Now in the end, we looked into how machine learning is helping in scaling, and the very famous example was Disney Plus Hotstar, where they anticipated everything before itself and pre-scaled their servers so that during the actual moment there were no issues, right? Okay, so this was all about it. Thank you guys, and this talk was not getting into technical details, right? Because I see most of the first years here, so I wanted to give an exposure to how actually the tech products work. Because in few months, few days, many of you will be working in corporates, right? So there you will see a different picture, right? Building app in college, in home is different. But if you see how the big companies work, right, it's completely different. So that was the agenda here. I wanted to give the exposure how the products actually work, how they are scaled, how they reach to millions of people, with ease. Okay. Thank you guys. Thank you very much.
The least niche of tech talks, it's going to be a long time, and I think most of you will agree. We'll go to the question and answer phase. So, if any of you guys have questions, ask them. Any questions, anyone? I think it's going to be a lot more easy to understand than the previous talk, right? Okay. Any questions? Okay, if you guys have more questions, then we'll wrap it up for today. This has been HackerTalks, and we hope to see you tomorrow at 5 p.m. where we'll be having another 3 HackerTalks. Another 3 set of HackerTalks. And if you guys have enjoyed it, and if you guys have any additional questions, you can come and reach out to the office right now. Thank you guys.